Right now, not yesterday, not a billion years ago, right now as you sit watching this video, your body is hurtling through space at 2 million kilometers per hour. Not the Earth spinning. Not the Earth orbiting the Sun. Your entire galaxy, the Milky Way, 400 billion stars, every human who has ever lived is being dragged at 2 million kilometers per hour towards something we cannot see. We have a name for it, the Great Attractor, and here is the part that should keep you up tonight. We do not know what it is. We cannot see it. It is hidden behind the thickest wall of dust in the known universe, and yet its gravitational pull is so enormous that it is dragging thousands of entire galaxies, not stars, galaxies, toward it like a drain pulling water. Stay with me, because by the end of this video, you are going to understand not just what the Great Attractor is, but what it might mean for the long-term fate of everything you have ever known. Let's slow down for a second, because I need you to actually feel how big this is. You know how fast a bullet travels? About 3 kilometers per second. Fast enough to cross your city in under a minute. The International Space Station, 28,000 kilometers per hour. Fast enough to circle the entire Earth in 90 minutes. Now here is where it gets surreal. Our solar system, the Sun, all 8 planets, every moon, every asteroid, orbits the center of the Milky Way at 800,000 kilometers per hour. That number is already incomprehensible, but our entire galaxy is moving at 2 million kilometers per hour. Faster than our own orbital speed, faster than the expansion of most of the universe around us. And it is not random. It is not drifting. It is being pulled. Something out there is pulling our galaxy like a magnet pulls iron filings. Something is calling us home, or calling us to our end. And for decades we could not even look at it. Here is why. Imagine you are trying to look across a city, but someone has placed a wall of thick smoke right in front of your eyes. You know something is on the other side. You can feel its heat, but you cannot see it. Not with your eyes, not with a regular telescope, not with anything that uses visible light. That is exactly the problem astronomers faced. The Great Attractor sits directly behind what scientists call the Zone of Avoidance, a region of the sky so dense with dust, gas and stars from our own galaxy that it blocks nearly all visible light coming from beyond it. For most of the 20th century, this region was simply a blank, a hole in our maps of the universe, a place we literally could not look. And yet the evidence of what was hidden there was undeniable. In the 1970s and 1980s, astronomers began noticing something deeply strange. Galaxies across a vast region of space, hundreds of millions of light years in every direction, were not moving the way the Big Bang expansion alone could explain. They were being pulled sideways, pulled toward a single point behind the wall. In 1986, a team of astronomers called the Seven Samurai, yes, that was their actual nickname, mapped the motion of hundreds of galaxies and confirmed it. There was something there. Something massive beyond imagination. They called it the Great Attractor, but they still could not see it. For decades, the Great Attractor was a ghost, a force without a face. Then we changed what we were looking with. Instead of visible light, astronomers turned to X-ray telescopes and radio waves, wavelengths that can pierce the dust cloud, like radio signals pass through walls. And what they found there rewrote our understanding of cosmic structure. The Great Attractor is not a single object. It is not a supermassive black hole, though there are plenty of those there. It is a gravitational convergence zone, a region of space where the combined mass of thousands of galaxies, dark matter, hot gas, and structures we are still mapping creates a gravitational pull of almost incomprehensible magnitude. At the center of this region sits the Norma cluster, one of the densest galaxy clusters in the observable universe. Hundreds of galaxies packed into a region of space, their combined gravity amplified by dark matter halos surrounding them. But here is the twist, and this is where it gets truly mind-bending. The Great Attractor is not even the biggest thing pulling us. It is just the nearest. Behind it, further still, even harder to see, lies the Shapley Supercluster, a structure so massive it contains the equivalent of 10,000 Milky Ways worth of mass. And it is pulling the Great Attractor, which is pulling us. We are not falling into one drain. We are falling into a drain that is itself falling into a bigger drain. Here is the question you have probably been sitting with since the first 30 seconds of this video. Are we in danger? Short answer, no. And the reason why tells you something profound about the scale of the universe. The Great Attractor is approximately 250 million light-years away. Even at 2 million kilometers per hour, it would take our galaxy billions upon billions of years to reach it. And by that time, the accelerating expansion of the universe will likely stretch space itself so dramatically that the Great Attractor's gravitational influence will weaken and eventually reverse. In fact, cosmologists believe that on long enough timescales, the expansion of the universe wins. The Great Attractor does not swallow us. Instead, as the universe expands, we may eventually lose sight of it entirely, along with most of the galaxies we can currently see. We are not being consumed. We are passengers on a river that has no final destination we will ever reach. But here is what that answer hides. It tells, as we live in a universe of inconceivable violence and beauty, where forces too large to comprehend are constantly reshaping the structure of reality. And we, on this tiny speck of rock, have somehow developed the mathematics to detect it, name it, and begin to understand it. The discovery of the Great Attractor led scientists to ask a bigger question. If all these galaxies are flowing toward the same point, what is the actual boundary of our cosmic neighborhood? In 2014, a team led by astronomer Brent Tully answered that question in a way that changed everything, by mapping the motion of over 8,000 galaxies, not where they are, but where they are going. Tully's team was able to trace the flow of matter across space like mapping currents in an ocean. And what emerged from that map was a structure of staggering size. They called it Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea is a supercluster, a vast web of galaxy groups and clusters, 500 million light-years across, containing the mass of 100 million billion suns. The Milky Way sits on its outer edge, a tiny suburb on the fringe of a cosmic metropolis, and at Laniakea's heart, the Great Attractor, our supercluster's gravitational center, the drain toward which every galaxy in our cosmic neighborhood is slowly, inevitably flowing. For the first time in history, we could look at a map and say, this is where we are. Not just in the solar system, not just in the galaxy, but in the universe. We are here, on the outer rim of Laniakea, falling slowly inward, part of a structure so large it makes the Milky Way look like a single grain of sand on a beach that stretches beyond the horizon. Here is what I keep coming back to. Every map we have ever drawn has changed how we understood our place in the world. When Copernicus told us the Earth orbits the Sun, it did not just change astronomy. It changed philosophy, religion, the very concept of human significance. When Hubble showed us that the Milky Way is just one of billions of galaxies, it did the same thing again, and now we have Laniakea, a map that shows us we are not even at the center of our own supercluster. We are on the edge, passengers on the outer rim, being pulled, along with hundreds of thousands of other galaxies, toward a gravitational center we spent decades unable to see. The Great Attractor is not just an astronomical curiosity, it is a mirror. How it forces us to confront the fact that the universe does not care about our coordinates, our borders, our sense of self-importance. There are forces at work, forces that operate on scales of hundreds of millions of light-years, that will reshape everything long after the last human memory has faded. And yet, here we are, a species that evolved on a rock, orbiting a medium-sized star in the suburbs of a galaxy on the outer edge of a supercluster. And we figured it out. We mapped the drain, we named it, we measured it. That to me is the most extraordinary thing in this entire story. So here is where I leave you, 2 million kilometers per hour. Right now, as you watch this, as you breathe, you are on a planet, orbiting a star inside a galaxy, inside a supercluster, falling slowly, magnificently, unstoppably, toward a gravitational anomaly hidden behind a wall of cosmic dust 250 million light-years away. You will never get there. Your grandchildren will never get there. No human who has ever lived or ever will live will get there. And yet the pull is real. The motion is real. The universe is doing this with or without our permission, our knowledge or our fear. The Great Attractor does not need us to believe in it. One last thought. We named our supercluster Laniakea, Immeasurable Heaven. The people who named it were astronomers in Hawaii, looking up at the same sky their ancestors navigated the Pacific Ocean by for thousands of years. They crossed half a planet using only stars. We crossed the entire observable universe using mathematics. Both of them required the same thing: the courage to look up and the will to map the unknown. What unknown are you willing to map? If this changed how you see the universe, even slightly, share it and subscribe, because next week we go somewhere even stranger.